Okay, thank you everybody for joining us after lunch. For those that were not with us this morning, my name is Jeremy Koop. I'm the ATD-2 analytics lead, and this afternoon we'll hear a talk from Dr. Andrew Churchill. This morning we talked a little bit about some of the data elements that are captured in our Fuser database and how we generate, or how we turn the Fuser database into a consistent report where each row is an individual flight, and then we have, somewhere like around 400, 450 columns of different data elements for each unique flight. This afternoon, we'll talk a little bit about some kind of extensions of the flight summary, which we call the TOS summary and the TMI summary. And the key idea here is the same idea, which is we're trying to build these consistent reports that allow our analysts to kind of build more complex analysis or data products on top of, but we want that foundational data element to be sound. And so without further ado, Andrew will get us started and talk about the TOS summary and TMI summary.
All right, thanks, Jeremy. So for those of you here this morning, the title of the session is the same. So it is in some ways a continuation, but if you weren't here this morning, don't worry. You'll be fine keeping up with this, I think. And please feel free to stop me at any time if you have questions or something's not clear, or you want to dig into something a little bit. We have enough time to go into that. So the title of the session: SwimFuse Data Products Used by ATD-2 and Analysts for Quantifying NASA Performance and Benefits. That's really a long way of saying this is our reporting. So we do, as a foundation for the analytics, the predictive and prescriptive analytics we want to do, we have to do some reporting and some data standardization first, and that's what we're really talking about here. How do we turn these big, messy databases into artifacts that most analysts can work with to really get their stuff done and gain some insights from the data that the systems are generating. So this is session 2 of our reporting track here. So we're going to describe the other 2 core data files. As Jeremy said earlier, we talked about the flight summary file, which takes a flight-specific view. So when you open the flight summary file in Excel, for example, one row is one flight, and every column is a different metric for that flight. So parallel to that, in this session, we're going to talk about the TMI summary and the TOS summary. The acronyms are TMI for Traffic Management Initiative and TOS for Trajectory Option Set. So in each of these, the TMI summary, a row of that is a individual TMI, so a traffic management initiative imposed by the FAA to address demand capacity imbalances. And the TOS, each row in there is one flight's trajectory, or one flight's route in their trajectory option set. So one of the candidates that's being considered for use for sort of routing around the situations that concept is trying to address. And I'll talk a little bit about that so that it makes sense in context. We get to it later on. Talk a little bit about some of the reports, again, that are built on top of these, and of course, lots of question and answers. So again, feel free to stop me. So just to go over the background again, why are we worried about this? Why have we put so much effort into reporting here? I mean, I think any sort of, the modern data science industry or analytics consultants will tell you that you have to have sort of good business intelligence before you move on to sort of the higher levels on the analytics maturity curve, and that's really what we're trying to build, a good solid foundation here for everything else we're doing. So these systems that we're running for ATD-2 ingest huge amounts of data from swim and airline partners and other feeds. They do all kinds of data fusion to match it up, so we have a common view in the system of what a flight looks like. They make a bunch of predictions based on that, and they output this data then, and that output ends up, it feeds some of the displays that are used in operations. Some of that data flows out in the TTP feed, which you may have heard about, and then it also goes into these big data warehouses. So there's this huge amount of data flowing out every day. Not terabytes like the FAA was talking about with the swim, but gigabytes a day. It was a considerable amount of data. And that scale problem introduces challenges for individual analysts working with it, just from a computational and time perspective. We only have so many of these big servers. Besides scale being a challenge, the data contains noise, grouping a bunch of different things here that are sort of sources of noise in the data. Human inputs, the ramp tool that's used at Charlotte, and the negotiation of the overhead slots. There's actual humans inputting data and interacting with the system. Anytime you have that, there's potential for some noise, so we have to try to make sure we're accounting for that in our analysis and trying to standardize our approach for that. And that's kind of logic we're trying to roll into these products. Complexities of data mediation, order of processing messages. There's a lot of, when you get down to the nitty-gritty details, there's a lot of challenges there. And if we can abstract that away for analysts, we can save a lot of time and sort of multiply their efforts. The software has changed over time. There's been new features added. We want to try to maintain some backward compatibility and figure out how we can infer some of that historical data. There's been changes to how values are computed and recorded, and we're trying to compensate for all of that in one place. So those are sort of the standard conventions we're trying to keep track of here for measurement, and do it all in one place to make things simpler for everybody. So we've developed these standardized reports, the files, and then reports on top of them to serve analyst and user needs. So some of the data is, it's archived at NASA, it's used by NASA analysts, and it's also pushed out to some of the partners as well. So the core data files, as I said again earlier, we talked about the flight summary report. This session, we're going to talk about the TMI summary. So each row in that file is a distinct traffic management initiative. And then in the TOS summary file, each row is a distinct route for one flight and the data about that route that it could have, maybe it did take, maybe it didn't take, but it could have taken, leaving the North Texas region here as part of the ATD-2 phase 3 concept. So we'll talk about the TMI summary report first and the different kind of data that we include there, some of the things we use it for, things we want to add to it, and then the TOS summary we'll talk about second. So just a little background, motivation about why we're trying to collect the data about the TMI summary report here. It can be difficult to access this data in convenient machine-readable ways, I would say. So many people are probably familiar with the FAA's OIS webpage. There's a lot of information there about status of different NASA resources, different traffic management initiatives that have been put in place. But it's tough to use that. It's easy for humans to read it, look at it, and if you're an expert to sort of infer the state of the system. But if we want a standardized way we can load this data up, particularly for sort of a longitudinal analysis, we need some standardized format that we can maintain. So we need to get that kind of data into one place, not only to feed the system, but for us to perform our analysis. So the ATD-2 system, sort of the data back end, parses data from one of the SWIM feeds that provides this sort of information. It looks at the OIS web page and tries to turn that into machine-readable text, and receives user inputs. Particularly in the North Texas region, users do input specific miles and trail or fixed closure. They update and change those, and it gets into the system that way. So this data is used in the system for some of the scheduling, for some of the situational awareness stuff that happens on display. But on the analysis side, we also want to be able to segregate our data, for example, and say, what happened during different kinds of restrictions, or how were flights with different kinds of restrictions treated, or what happened on days where the conditions were like this versus days the conditions were like that. And having this kind of data available allows us to answer those questions.
And can I jump in here real quick? And maybe just to provide a little bit of context. So in ATD-2, we have 3 distinct phases of our work. And the phase 3 work is different than phase 1 and 2, which was focused at Charlotte and on surface metering. And part of the workshop tomorrow morning will be a discussion about our phase 3 work. But the idea mainly is, when you have a metroplex environment like we have here in the North Texas region, and you have multiple airports sharing a common resource such as a departure fix, when the demand for that fix overloads the available capacity, whether that be because of restrictions or weather or whatever, then delay starts getting passed back to the airport surface. And if the operators were to provide us a set of alternative routes that they're willing to fly, if the delay savings gets high enough, then we could route them through those alternative fixes. And so that's kind of the context of what this report is used for, is that it's giving us insights into those restrictions and then also into those kind of sets of alternative routes, because ultimately we want to kind of take what the operators give us, which is, hey, I'm willing to fly these sets of routes, just kind of find the most efficient route for me, and then the system does that in the back end.
That's great. That's great context. Thank you. So it's good to think of these 2 core data files in conjunction with each other, because they often they support each other. being able to look at how TOS, what kind of TOS activity is going on under given TMI conditions. It's available in the other file. So 5 different traffic management initiatives that we are capturing data on, the data is being used in the system and that we're capturing on in this file. Some of these I talked about earlier because we capture some flight-specific data about each of these. So that's sort of working from the bottom up. The flights are included in the program, and in the flight summary file, we include the impact of that TMI on the flight. You know, what time was it scheduled, for example? What miles in trail was that flight impacted by? From this file, we're looking from the opposite perspective, from the top down. So for the whole program, when did it start? What were the rates that were included in it? What were the alternative fixes specified? What were the operational parameters? So, I mean, you can sort of infer the top level from the flight specific, but not entirely. You don't have the complete view. So we're trying to attack the problem sort of from both sides, from a flight specific view as well as a program-wide view. So the 5 traffic management initiatives that we look at here, ground delay programs, many people are probably familiar with that, you know, sort of an outcome of the CDM process long ago to manage traffic imbalances at destination airports. Ground stops, similar idea, you know, sort of a more severe version of a ground delay program where the rate goes to 0 and flights can't take off to arrive at that airport till the ground stop is lifted. Miles in trail, those can be across a fix or to a destination. It says, you know, all the flights out of North Texas to Atlanta have to be 25 miles apart, for example. Or all the flights across the Torch fix have to be 10 miles apart. Fix closures, you know, if there's pretty severe convective weather, for example, across a couple fixes, they'll just say these are closed. Those flights all need to be routed to these other fixes. And APREX, so we talked a bit about APREX earlier. That's a huge area of focus at the work ATD-2 has been doing at Charlotte for phase 1 and phase 2 in terms of negotiating flights insertion into the overhead stream, which has been the bottom-up view I was talking about. You know, what time did that flight request? What time was it assigned? How much delay was associated with that assignment? This is the top-down view that says APREX were required for flights going to this destination, you know, between this time, and then a user adjusted it or canceled it at this time. So we're trying to capture that data here. So, you know, right now we're capturing this raw data, and I'll talk about a little bit more about what data for each TMI we're capturing. That's captured and archived and used for analysis. We also push that data, we sort of format it, clean it up a little bit, push it to researchers and users each morning so that everyone has sort of a common view of you know, what happened the prior day here in the North Texas region in terms of restrictions. So different pieces that we capture in general for the TMI data. We capture the creation time. So what time, you know, did someone, all the TMIs essentially come down to someone somewhere entering the data into an automation system, whether it's into NTML or some FAA automation, or whether it's into one of the ATD-2 interfaces. A person is putting that data in. So we capture what time did they put it in, what time did they plan for that program, that in restriction to start, what time did they plan for it to end, what time did it actually end, which, you know, is often different. What resource was affected? You know, is it an airport? Is it a fix? What's the name of that? Was there an alternate specified? You know, for the example of a fix closure, they usually say, you know, instead these flights are directed there. For MITs, what's the spacing? And we also capture quite a bit of information about constraints. And I think there's a lot of interesting data there in the constraints that is, you know, they'll enter that the restriction only includes or only excludes, you know, certain aircraft types. Flights going through some specific fix or departure gate at or above or at or below some altitude, or specific airlines or call signs, you know, maybe included or excluded. For whatever reason, you know, we don't have visibility on this side into why that decision was made to include or exclude those flights, but there was some decision made there, and we capture that data. So, show a couple examples of what we've got here. Hopefully you can read the table there, maybe not. If not, check out the slides afterwards. So for ground delay programs, you know, we capture the parameters of them at destinations for flights leaving the sort of airport that we're studying. So the flights leaving North Texas, both from Love Field and DFW, have the same restrictions applied because they're in the same center here. So, you know, we sort of capture that in one place for both airports. So here's an example. You know, there's programs in place at 4 airports there. Probably you can't read the airports here. We have SFO, Newark, LaGuardia, Boston, and JFK. And this column says, how did the program end? Was it ended because someone canceled it and ended it before the planned end time, or did it expire because it ran through the planned end time and just was lapsed? So most of these were canceled. Boston was actually ended a bit early. I can't even read what the end time there was, but it was, for whatever reason, maybe the weather cleared early. They didn't need that restriction in place at Boston anymore, so they canceled it. And we have the EDCTs associated with each flight. They're included in these, and those are already in the flight summary file. So, GDPs have been, they've been examined by a lot of research. There's been a lot of different prototype tools developed to support them. So GDPs, I feel like the data around them has been sort of better analyzed over time. We don't capture the rates here, but certainly others have looked at that. It's a potential future improvement we could get because the data is there in the feed. We're just not capturing it because we don't really need it in the context of the ATD-2 system. Ground stops, like GDPs, they have been pretty widely studied. They're sort of a special case of a GDP in any case. So we capture the same sort of data here about where and when those are taking place. This example here was on July 22nd. There was pretty significant storms rolled across most of the country that day. And you can sort of see the progression, if you could read the times, as the storms hit these different airports across the Northeast as they were closed and opened for the ground stop. We capture things like the reason that a program was put in place, which is sometimes data that's entered, sometimes it's not. That one there, for example, for Nashville, there was thunderstorms that they were included, so that we capture that sort of remark. No inclusions or exclusions specifically here, but like I said, we do parse those and record them. One thing that's interesting here in this example is that sometimes they'll revise TMIs, and that's common, for GDPs to adjust them for ground stops, whatever they might change the scope. Sometimes those come through looking like new programs altogether. So for example, the two highlighted rows here are both Nashville. The times actually overlap, but the way they're identified in the system, they look like a whole new program. So that's how we capture it. So that's an area we're actively working on to figure out, is there a better way we should represent this as sort of a change to an existing program versus a new one, and trying to struggle through those questions because it's a sort of a ripe new area that I don't think has been looked at from a data side terribly a lot. So ground delay programs, ground stops, fairly well studied. We get into miles and trail. From my perspective, it's something that's not been as well studied. There's not as much visibility into it because it's more of a local restriction. But the data is coming through. Like I said, we capture the rate that was imposed, the distance separation across the fix or to the destination that's required, that's been imposed. In this example here, we have some restrictions that came through the TFM feed that were entered in NTML. We have some that were entered locally into the ATD-2 system. So we have an indication of the source here. We have some examples here where we have fixes. So we don't differentiate from a display point of view. In the underlying data, we actually do indicate whether the downstream resource is a fix or an airport. Makes it easier for analysis, but in the display, we assume that the people receiving the report know that if it's got 5 letters, it's a fix, and if it's got 3 letters, like ATL here, that it's a destination. So there's enough flights. Sometimes they need to put those kind of restrictions in place. Enough flights, for example, from North Texas region out to Atlanta. They need to make sure those are spaced out enough. They're not creating problems. And so we're able to capture that data. The data is used in the system, obviously, for all the different scheduling that's happening in the display. But we want to be able to look at it in a sort of post-analysis way, and that's the purpose of capturing it here. So some of these, another thing that's interesting, I'll say, that's sort of an artifact of how the data is entered and how the tool is used and interacted with by the users. When data is entered by a user, sometimes they enter a planned end time, and sometimes they don't. Sometimes they just enter a restriction that says, started at this time and run until it's ended by a person, or it expires overnight. We sort of expire all the restrictions at 3 a.m. or something and clear the system out. But that's just the way they use it a lot of time. They don't have an end time in mind. So like miles and trail, we capture data on fix closures. So fix closures, it says this fix is closed for traffic. Don't take off. You're coming here. You could take off going to this other one, but you got to get spaced out because now that one's probably overloaded. So we capture the alternate fix and the associated gate, which is essentially the direction of travel. The North Texas region here, the TRACON here is a nice shape, so it's easy to have the north, south, east, west sides of it. We can associate each fix with a gate aside of that volume. And so we can group those fixes together in that way and record the data here, So, some of the things that are interesting here, we capture sometimes where there's a fix with a specific alternate specified and which direction of travel that's got to be. Some other ones are captured as out the gate, and that's sort of when part of that direction of travel is blocked, and then the controllers have some increased flexibility as to how they route those flights. Rather than specifying a single alternate, they have some flexibility in where they're putting them. So we're able to capture that because that's how it's entered, and it's entered that way coming through the TFM swim feed, so we capture that data. Again, the same idea. If it's entered in the swim feed, they have to enter an end time, so we get that planned end time, and we can see if it's canceled early, or if it runs till the actual end time matches the planned end time. It runs, it sort of naturally expires. So, really good visibility into something that I feel like I haven't seen data elsewhere on. That what's the actual schedule of these happening? We haven't correlated this to weather data. I mean, obviously, the idea of weather data is a huge nebulous concept. There's all kinds of weather data, but there's a tremendous amount of value, I think, here that could be realized by comparing this to weather data and say, this kind of weather rolling through, what kind of restrictions are typically imposed, and be able to quantify that. And if you get enough of the data, then say, what is a more or less effective strategy? What realize more or less delay? And this data gives you that kind of visibility because it's now coming through SWIM. We're using it. We're capturing it. So.
And one thing to add when we're talking here about the restriction data is that one of the things I think that we found is that the facilities like to use their own language per se for different types of restrictions, and that to standardize that was something that we actively had to do. So for example, the controllers in ZFW might say, or in D10 might say, put the outers on the inners, and they know what that means. But that might mean something different to somebody at a different facility. And so, when you think about generating these type of reports across the NAS, there still needs to be some synchronization between the centers so that you can kind of all get on the same page there.
Yeah, I mean, setting up for sort of a local facility, it's a combination of sort of adapting to the local standards as well as some training with the people entering the data to make sure that everyone's on the same page, that even everyone in the facility is using the same terminology, so that the system is able to interpret it and record it in this sort of uniform way that lets us do this long-term analysis. So that's what's in our TMI summary report. Are there any questions specific to that people want to get into before we start talking about the trajectory option set, the TOS summary report?
So yeah, I got
app here.
A question from the app here, which is, do you capture TMI data for arrivals? For example, GDP at Charlotte or TBFM metering into Charlotte DFW, or MIT requested by ZFW for arrivals into DFW?
So we do have the data available at least for GDPs into the local facility. We don't record it here in this file specifically, but it would be straightforward to add. It's in the same part of the database. Just that so far our focus on this particular artifact has been in relationship to departure, restrictions on departures. So, but I think that's an area where we could do a lot more work. Any other questions on TMIs before we start talking about trajectory options?
This is, do you want me to go to the microphone?
Yeah, actually, if you can speak in the microphone, that helps recording.
So this is great information to have. Do you guys plan on turning on the SMP service for the TTP demo and plug this stuff in to the corresponding fix'em fields?
Yeah, I believe that our plan is to kind of start to push out the TTP feed as close to what we think TFDM will look like in the future.
Okay,
and
great.
So that we want to prepare the operators, the community, for what's coming down the line. So I think, our vision would be that, yes, if we have the data and we're able to start pushing it out, we would do our best to replicate what TFDM's TTP feed would look like.
And if that's something that would be really useful from your perspective, make sure that, Al and others in the leadership hear that, because there's only so much time and so many people left to implement this kind of stuff before the project ends. So
Great, thank you.
definitely that's the kind of feedback they want. All right, so that's TMIs, the traffic management initiatives, and how we look at the data for that from an analysis point of view, how we standardize that. Now we will talk, oh my gosh, I'm ending it here too soon. APRECs, so we also capture APRECs when the restrictions for, APREC is an approval request. It's sort of an evolution of the call for release process for scheduling a slot in the overhead stream. We talk about that quite a bit with the flight summary file. We have quite a bit of visibility on the flight level, what times were requested and when they were scheduled and what delay was assigned. But we also now capture, what was the overall scope of the restriction, when did it start, when did it end, to what destination, how long was it in place. We do also capture some inclusions and exclusions. So here's an exclusion, for whatever reason that United flight was excluded that day, however that worked out. A little bit less, we have pretty good visibility into that already from the flight level, but this is just sort of, completing the circle because we have this data. So now we can talk about TOS summary. Those are the 5 TMI types we have. So Jeremy explained the TOS concept real briefly a minute ago. There's other sessions that'll explain it in much greater detail and what's actually happening with it. But the point is that the graphic sort of tells a story. If this is the airports here in the North Texas region and you've got a storm here blocking these 3 out of the 4 fixes, all these flights could continue to go to that one fix and take a ton of delay. Or they could maybe fly a longer route out one of these other directions of travel and fly a little bit further but get out sooner. And so the idea of the phase 3 TOS concept that's been implemented here is to automate that route generation, negotiation, approval process, and implement sort of the decision process that the airlines have to be able to make those trade-off decisions. So to support that, we need to be able to do analysis to understand how well is the concept working, what are the benefits that are associated with it, what are the costs associated with it. So we've developed a similar file called the TOS summary, creatively named, that rather than having 1 line per flight, it has 1 line per flight and route. So an individual flight, that's impacted by a restriction like this, that wants to go this way, but it's going to wait forever to be able to go that way, and it's filed sort of preferred route. We might generate a couple routes going north, a couple routes going south. So there's multiple TOS options that are available for that flight. And that lets us, understand what is the delay associated with each of those, what is the extra distance flown, how long do they have to wait to take off, they have to change runways. There's all kinds of questions we can answer, and we can roll things up in different ways to look at that. And as you'll hear, the phase 3 concept has really only started being in use for a couple months, so we're still gathering data, understanding the exact needs. So this artifact, this report is very much still evolving, but I think it's already, the underlying piece of the analysis for some of the presentations that you'll see talking about the TOS operation so far. So the different groups of fields that we have in here, 3 sort of primary groups of data, if you will. Basic descriptive data, and some of this is really helpful just to let us join back to the flight summary file to say, we know here's a TOS route we're interested in for this flight. What is the whole view of the life cycle of that flight that we have available back in the flight summary file? So things like the call sign, the Goofy, which is this globally unique flight identifier. If you haven't heard that term before, it's sort of a broad concept for just a unique flight identification token. Origin destination, the origin here being DFW or Love Field, and where it's going helps us understand performance in different directions of travel. The marketing carrier, we have some visibility now into the regional major relationships, so we can see who's the major that that flight's operating for. The originally filed route, so we can see which way the flight sort of wanted to go initially. That gives us an idea sort of what the airline preference was. What was the final filed route? So if that may have changed. It may have changed in response to just the airline decision process. It may have changed in response to the TOS negotiation process. We have the actual time, so the acronyms there for the actual off-block time, the actual movement area time, and the actual takeoff time, and also the queue entry time. So those are sort of for departures, the 4 major milestones on the surface. Which runway did the flight actually use? That helps us understand quite a bit about differential performance around the airport. At DFW, not an issue really at Love Field as much. And then for each of these TOS options, because remember a row here is not just a flight, a row is a flight on some TOS option number 1, TOS option number 2, 3, and so on.
Can I just add one thing? So for those familiar with the operations for the ATD-2 phase 3 concept, our trajectory option set, or TOS, is just a set of coded departure routes that the operators submit. And so you can think, we discretize the problem into this handful of candidate routes that are defined by the coded departure routes, or CDRs.
Yeah, and you could, the approach that I'm describing here is agnostic to that. That's sort of all happening upstream in the back-end systems as to what routes are actually options. Here, we show a route.
Do you have any numbers on how often the pilots are accepting the routes you suggest?
So the question was, do we have data related to how often pilots or ATC or, the turn coordinator, whoever? Yeah, we do have data. We're actually in the process of essentially running this system for the very first time ever, and that stuff we're actively gathering, trying to understand when is this useful, how useful is it, what type of conditions have to be met such that you have a viable alternative route. So we don't have answers on that right now, but we're in the process of collecting that data.
Yeah, and this is the way we're going to answer those questions. We're starting to answer those questions already. So like I said, each row here is a flight and an individual, CDR, an individual TOS option. So for that TOS option there, the last one we have there, we have what fix is it now going to go over were it to take that TOS option? What gate or what direction of travel is that, north, south, east, west? What is the distance that's associated with that new route, and how does that compare to the filed route, the originally filed route? And what is the route string associated with that TOS option? So we want to be able to get that route-specific data to evaluate, what are sort of the characteristics of this route, and how does that fit in for this flight? So.
The question was, do we consider the changes that happen in air to flight plans? So for the ATD-2 phase 3 concept, we essentially are kind of focusing on pre-departure, so that this kind of thing should happen, ideally when aircraft is still at the gate in the ramp area. The system's flexible that all the way until actual off, you can make that decision, but the operators are the ones who are kind of defining the parameters of when we're allowed to play this game and when we're not. The system is flexible to, while you're still on the surface, we could reroute you, but the airlines kind of are making those decisions.
And that's actually a great question. Let me raise one issue that comes from that. We have these three different files, the flight summary, the TMI summary, and the TOS summary. That's actually something we capture in the flight summary because it's sort of an innate characteristic of the flight is how many times that route changed and what were those different route strings that were filed. So we capture it there on a flight-by-flight level. So if you want to sort of compare those changes and when they happen against the data for individual TOS routes, and it's sort of combining the files. And what is the division between these different files is an active question. And it's we've made some judgment calls on that, and it's still something we're trying to get right.
Final file draft string here would be the final file prior to departure, and what's in the other files might be different for the final file.
Yeah, if it's being changed, if it's being refiled after it's departed, after it's left the runway there, we're not capturing that here. The reason we're capturing the initial and the filed here is so we can compare for each TOS route, is that the same route string? Was this the one? Independent of the sort of approval process, we can compare the route string and say, well, maybe they didn't go through the official process, but did they actually end up just filing this route? That gives us some valuable insight into the decision-making process. Other questions? Feel free to interrupt me. I know not everyone is familiar with the TOS concept and how it's being implemented here, so it's a little difficult to talk about what we're doing with the data without knowing the concept, I guess. So other data we capture about each flight and TOS route, we capture the quote-unquote participation level. And so in this file, we actually capture it at a sort of flight level with the same column across all the fields, as well as on a route-by-route level, answering questions like, was this TOS route for that flight ever a candidate, which means, was there a benefit that could be realized by taking that route? Did the delay savings exceed the sort of quote unquote cost of flying the extra route? However that decision is being made, we're agnostic to that, but did it achieve that status? Was it submitted by the operator? The operator say, we want to take this TOS option, we want to take this route and fly this different route. Was it approved by ATC? And then also, was it unsubmitted? Because they can say, maybe we don't want to do that one anymore because conditions have changed or whatever. Or was it unapproved by ATC? We're able to capture that action. And then we also capture an indicator of whether it was filed. So once it's approved, there's still a separate step of that being filed and the flight plan being disseminated. So we also capture information on when the flights and the routes enter candidate status. So that's when the benefit pool becomes available and we think that it's going to be a beneficial change to make. The final submission and approval times, because depending on the complexity of the operation that day, there may be multiple submissions for a given flight. There may be multiple approvals and unapprovals. We want to make sure we're capturing the full life cycle of what's happening for that flight for each route. And then times that we transition from potential to candidate and back candidate to potential, because as the situation evolves, a route for a given flight that may have gone to candidate status may just go back and not be a candidate anymore because based on the state of the system, the benefit pool no longer exists. So we're trying to capture that.
So as part of that, do you capture if it kind of goes back and forth multiple times?
Yep. How many times it makes that switch? Yep.
Yeah, the question was, do we capture if the flight status oscillates back and forth? And yes, the system will capture that.
It's fairly stable, so we don't see a ton of that. It's not cycling really, not in a dramatic way. But yeah, that's something we're definitely trying to keep an eye on using this. Okay, and then for each of these routes, as with the flight summary file, we capture predictions, time and resource predictions at events. So for a flight, a given route, at a long list of events there. So this file ends up really wide because we're sampling all those values at each of those events. So you have sort of a factorial problem here. But at the sort of normal flight life cycle events, as well as the submission, approval, transition into potential benefit or not. We capture at each of those events, what's the ELBT? And it's coming back to, we talked about earlier, the importance of good ELBTs and that data feeding in. It's critical to this system too to understand, as the scheduler is making predictions for when this flight is going to be able to take off and cross the fix and fitting that in with all the other flights. It's only based on a prediction. So our ability to schedule that is only as good as the prediction we're getting for the ELBT from the airlines. And then different artifacts that come out of the scheduler here for the unimpeded takeoff time, UTOT, target takeoff time, and estimated takeoff time. The peculiarities of all these different ones are not that important in this context. We can talk about it offline or in a different session. But we're sampling these values that are coming out of the scheduler at all these different events. Likewise, those are takeoff times. We also capture the times that flights we expect, or they could, or maybe they will, cross the fix. And that changes over time as the scheduler updates and new data is received and new ELBTs are changed. At each of these milestones, we capture the so-called coordination status, and that's whether this toss route has been submitted or whether it's been approved or whether it's been refiled. So we can see, as the flight progresses, where in its life cycle did these different things happen, rather than, what did it ever happen, but where in the life cycle did it happen. Eligibility status, that's this notion of, being a candidate route or not, whether the benefit pool exists. We capture is the currently filed route, which is sort of the converse of some of the things I already said. We capture this, we have this notion of top route, where we have an algorithm for inferring, what is the top route for this flight right now. And it's based on, has the airline already submitted this? If they've already submitted, they probably think it's the top route. But if they haven't submitted it, maybe they submitted it in the past and unsubmitted it, probably it's not the top route. Well, if we don't know that, which one has the most benefit pool from our estimation? And that's probably going to be our best guess for what's happening. And there's even a more complex hierarchy for how we infer that, but we want to try to say, is this what we currently believe the airline should or would do right now? The RTC, so this is a different RTC than we talked about in terms of the ramp controller tool. This is the relative trajectory cost. So that's a way of, this concept is not new to ATD-2. It's been used in some other FAA concepts, for example, the CTOP program. The RTC here helps quantify the trade-off between delay on the ground, additional delay on the ground to standard preferred route, and extra flight time, flying this route that's a little bit longer, but is going to get you off the ground sooner. So it's a way to quantify that trade-off and help the system sort of optimize that. We capture the expected runway associated with each of the routes that's predicted at each event. That's fairly static across the life cycle of the flight. I mean, if the airport were to flip around, for example, that's going to change. But otherwise, you know, if you're going to this fix, you're generally using this runway, and that's static on a given route. And then we capture various measures of delay. So we have a lot of different ways of measuring delay for a given toss route based on sort of what your anchor point is. You know, if you're comparing against the scheduled times, or an estimated time, or an unimpeded time. There's different ways to anchor that delay and compute it. And we're trying to capture all those at these different events to be able to look at how the delay evolves and compare that against sort of the decision process too. When we look at flights, you know, was this route ever submitted? What was the delay when it was submitted? And we have visibility now to that. Without digging into this very large database table, we can go right to this file and see that.
And one more point on the delay that, you know, as the researcher, I find quite interesting is that, you know, we're talking about delay being passed back from the terminal fix to the surface. And through our system, we're actually able to start to measure how much of the overall delay is from the surface congestion versus how much of that delay is being passed back by the terminal fix. And that becomes interesting, and you can think of, you know, as the operator, your decision of when to reroute or if it's worth rerouting could be informed by the fact that this delay is purely based on the terminal fix. This delay is coming just from general surface congestion. So the system remains kind of very we have high fidelity data elements that allow us to kind of measure the distinction between terminal and surface delay.
And in some sense, what we're talking about here, I know it's more abstract, certainly. You know, talking about the flight summary file is something that most of that you could compute from what's going to come out of TFDM in the future, right? This is a whole different concept. So we're trying to capture different data elements. It's much more of a research exercise, I would say, to be able to know which data elements are we going to need to evaluate this it's not a totally new concept, but this totally new implementation of this concept. Because it's a really dynamic concept with the way the routes are changing and the way the schedule is being updated continuously. To try to capture that dynamism in a simple file that people can use. And you know, we can't use it to answer every question we might have about the phase 3 operation, but we can use it to understand a lot of what's going on. And one thing we're doing with this file right now is we are rolling it up and generating sort of a summary of yesterday's toss operation. So earlier I talked about the daily data digest, which is something we developed initially for Charlotte to sort of describe, to quantify the operation the next day and say, here's how many flights were metered, and here's how long they were held, and here's how many flights took off in this time period. We're trying to get to the same thing with the toss operation. You know, it's a little bit lower intensity at this point, but we want to be ready for when, you know, the airlines really start ramping up and want to really explore the bounds of this concept. We want to be able to see how many flights were submitted and were unsubmitted, and which airlines did that, and where in the flight life cycle did they do that, and capture all these data. So we're generating that now. You know, there's not too many flights that are being included at this point, but we're able to summarize that, and we're trying to design some of what we're doing with these files with that kind of reporting in mind. Because, you know, a big part of this, before we even get to any real, you know, hardcore predictive modeling, just get everybody on the same page about what's actually happening with the toss operations is really valuable. And this file, and then, you know, sort of roll-ups on top of it, you know, get us a long way towards that. Okay. So, some of that I just said, you know, we summarize and push this to users each morning so everyone sort of sees what happened the prior day. You know, you can tell when there's a really busy day by looking at the TMI summary report and see a whole bunch of rows because there's a whole bunch of restrictions put in place. Or you can look at this toss summary one and see, oh my gosh, there was a whole bunch of flights that were entered candidate status, which means that they had a benefit pool that existed from routing to a different direction. And you see, oh my gosh, there's 100 flights that were candidates yesterday. That tells us a lot of information that the system is seeing a big benefit pool. Whether it's being realized or not, we're able to see that you know, we think it exists. So that roll up, you know, we send out some of the raw data so that the researchers and the team can really dig into it and, you know, understand what's going on, see if anything if they have any questions they want to follow up on, see if anything looks strange, you know, including things like, but at a summary level, things like delay savings as well, you know, so when these routes are activated and used, how much delay is being saved. We want to try to sum that up because that provides important insight into the overall benefit for the concept. So, that's all I have to say about the toss summary report. Are there any questions to that, or we want to just sort of move on to general questions? You know, this is just expanding on a reporting approach here that's really underlying a lot of the research and analysis that we're doing. The TMI summary, to me, I think is a really neat artifact. Some of the columns that are in there are not groundbreaking stuff, but to put it all in one place, I think is a fairly new thing. And hopefully people see value in that going forward. It can be, exist beyond sort of this project because there is a lot of potential utility there. And that one is practically all from swim data, given the assumptions about, standardization and training that Jeremy talked about a little bit about, but that's something that can be worked on going forward. So open it up for general questions or discussion.
I got one here from the conference IO. So we got the question, how do you deal with GDP messages that have multiple values such as rates?
So that's a good question. So right now we do not parse out the rate information and record that because it's nothing we really need to use in the ATD-2 system. So we're not building a general purpose data parser. Everything we've done has sort of been specific to our needs on the project. And we don't need to know the rates because we are getting the EDCTs, the control times for each flight included in that program. Going forward, the data is already there in the feed. We could parse it out. We could find a way to roll it up, but right now we're not.
And I would say that if the rate changes enough to impact that kind of EDCT time, we will get that EDCT time through our data feeds.
Yeah, we'll see the effect of it. But I think it's a great question because the data exists there. I don't know if anyone's capturing that and parsing it from the swim feed at this point, but it's a open challenge. I guess people could do that because it would provide new visibility that currently only exists in sort of very limited settings as to what those rates are. So. Yeah, definitely. How they're updated, yeah. Mm-hmm. Yep.
Yeah, or how accurate they are, all kinds of things.
Yeah, I think there's a lot of good questions there.
Question in the back.
Can you use the microphone?
How do you capture the same data, or how do you treat the same data that has been captured differently? For example, at DFW, when you push back from the gate, say Terminal D, the information is captured by SafeGate and reported by SafeGate. But Terminal E is manual, actually. The pilot tells you when they push back. So it's the same information, but captured differently. One has a human factor in it, and one has no human factor in it. How do you, I don't want to use the word clean, but how do you? No,
I understand what you're saying. So the question is, there's different systems that could be generating times. There's different mechanisms for how those times could be propagated, from the initial sort of acquiring system. What we're talking about here is agnostic to all that. That's all happening on the back end. It's feeding into the fuser, and there's been some discussion of the fuser. There's some sessions that talk a bit about that. The fuser handles all of that data acquisition, data processing, and formatting to put everything in a standard format. So that happens upstream of us. We don't have to solve that problem here, but it was a tremendous amount of work to build that architecture and implement all these different cases like you're talking about. The differences of how the data might be formatted from, from SafeGate versus an ACARS message, for example. Some of that even happening, further up. But the cleaning or the accuracy of those is something we've looked at from an analysis question, because in the flight summary file I talked about this morning, we do capture the sources of these different pushback times. So we're able to look at how those are different from each other and how they compare to the pilot ready time, for example, at Charlotte, where we do have that available. So we've done a lot of active research on there, a lot of which was used to sort of tune the system and improve our understanding of how we should use the system. But it's also given us some interesting insights into just how these systems work and what kind of data come out of them.
Yeah, so we have a lot of resources from Swift that we presented in May that talk a lot about the fuser and what kind of rules are in place. And even Andrew gave a talk about the different ETA predictions, whether it be from TBFM or TFMS, and when should I trust one over the other. And like he said, we build these rules that are supported by the data and analysis to try to just get the most accurate picture that we can.
How do you calculate the unimpeded taxi times?
Yeah, so Hanbong's in the room. So actually, Hanbong over here does a lot of work on that. I think that the main idea is, so we collect all the data about, the actual off-block time, the actual spot crossing time, the actual wheels up time. And then in the ramp, we have a philosophy that we use essentially the median values of those times. So because, you know, we think that the system, especially during surface metering, is operating under some type of congestion. And so the median values are a good representation of kind of, you know, not fully congested or something like that. In the active movement area, I believe in, I always get it backwards if it's the 10th percentile or 90th percentile, but that 10th percentile or fastest, if you look at the whole distribution, then that like 10th percentile is kind of how we define the unimpeded in the active movement area.
Yeah, Hambong has written several papers on this, and it's super interesting to me that he's tried all kinds of sophisticated machine learning algorithms to do this. And we keep coming back to these very simple approaches that provide us the best accuracy.
Is it by geographic location now?
So yeah, so we have great question. So we essentially have a surface model that's working under the hood, and depending on your gate, spot, runway combination, we generate a trajectory, and then those median taxi times are actually informing the velocity along that trajectory. And then what's nice about that kind of mechanism is that now you can think of, you can actually generate a trajectory from anywhere on the surface and then generate an ETA to some point, because all you're using is the velocity along that trajectory. And so it's very adaptable. Our surface model runs at a frequency once every 10 seconds. So you can imagine every 10 seconds we take a picture of the surface of the airport. We know where each aircraft is. We generate underlying trajectories, and then we use those velocity estimates to say, you know, this is how long the unimpeded taxi time is from where you are.
Also, another question about miles of trail. Are you showing on your miles of trail report any passback from one facility to the other?
No.
That's a good question. Yeah, I don't think so.
Center, you get a miles of trail restriction to an airport, and it's on the East Coast, and they put whatever 10 miles, and then the next center back puts on another 10 miles. You get 20.
Or 15 or
something. You get to the West Coast, you're at 100 miles of trail.
So yeah, the only way we capture that right now is in the flight summary report that I talked about earlier. We do capture multiple, if there are multiple MIT values, if there's one for a destination airport, and there's one for a local fix, we capture each of those values, and you know how that's implemented is sort of a local procedure, which one they prioritize, but we do capture just in that particular scenario.
But I think you bring up a great point, because we know that centers start requesting MITs, and then downstream facilities request even more MIT and stuff like that.
Everybody needs a little more than the person before them.
Yeah. So I think that's a great point.
And that's a great example where it's really hard to know how to parse that out of the data feed, and how do we represent it then in the system. I mean, which one of those is sort of the controlling one, right? Is it the furthest downstream or the furthest upstream, right? And there's a lot of good questions there we're just getting to, I think.
Okay, all right, thank you.
Thank you.
So are y'all pulling the miles and trail out of NTML, or are you actually looking at the miles and trail delivered?
Pull them out of NTML, yeah. So it's what's actually been delivered is a good question. I haven't looked at that.
We do look at what's delivered. So once a rate is kind of set, we have tools that we use kind of in the lab, you know, that we're not distributing, that we kind of say, okay, you know, 10 MITs in place. These aircraft kind of, we expect one every 2 minutes or so to kind of pass that fix. So we kind of keep track of that internally.
Is that shareable?
Yeah, I mean, we essentially know the aircraft that are under the restrictions, and then can just look at those histograms of kind of separations and things like that. If that's something you guys are interested in, I think that we can kind of share some of that analysis code.
Yeah, well, I am interested in it. I'd like to see what the sort of the standard deviation, just pick a facility.
Or maybe how it compares between two facilities.
Yep.
Sure.
Yep.
Yeah, and the other thing is, are y'all trying to reckon with the lack of relationship between flights? Say you've got a single line of flight that represents what an airplane does over the course of a day, that is subject to multiple TMIs, and understanding the relationship between fully downstream, the relationship of one flight to another and the TMI that's imposed upon it?
I would say that we have not kind of jumped into that pool yet of looking kind of, not just the life cycle of a flight, but like if you have a flight that goes, to multiple destinations, what kind of the ripple effects are. There has been some work, out of NASA that kind of looks like at accrued delay and things like that. And if flights are accruing delay, can we think of more fair ways to kind of, schedule them into these different restrictions? But on the ATD-2 dollar and dime, that's not something that we've kind of looked into.
There's been some other recent research there. I actually wrote my dissertation about pretty much that problem quite some time ago. But it's a really hard problem because it's such there's so many combinations that you get into a combinatorial explosion in terms of, all the different controls you could apply on this flight and all the different outcomes that has on the next flight in that line of flight. And then when you combine all the different lines of flight that you have, it's a really hard problem.
Just to narrow that a little bit, I was thinking in the context of how an airline operation manages those TMIs. So we don't want to get too far out in front of TMIs with the traveling public while we exercise mitigation over those impacts, distributing them across a set of decisions that involve multiple objectives, aircraft routings, maintenance requirements, crew limitations, all those things. So just in the context of AFPs and GDPs is what I was thinking for starters, and I'd love to see that paper.
Yeah, so I think our feeling is that these types of reports that Andrew's talking about here are the building blocks that would allow us to do that type of kind of analysis, and that once we can standardize these across different facilities and things like that, then if you really want to think about that kind of multiple leg route, that I think is where, we'll have a fighting chance to answer those questions.
And there's also some space here probably for the, in the future TFDM system where there's more information going back and forth between the airline and the FAA. When you get information this flight is subject to a restriction, whatever feed that's coming in on, you update your internal predictions. You push those back out, by way of ELBTs. It's that downstream effect is going to sort of propagate. And I think personally that's going to lead to some really interesting conclusions when that propagation of delay becomes more apparent.
So I think we've hit the end of the session. I want to respect everybody's time so they can go and have the 15 minutes before the next session. So we'll meet back here at 2 o'clock, and we'll see you then.